Hello and welcome back. Today we will talk about the internals of SSH agents. So last time when we signed host keys, we used SSH agent forwarding to somehow make the signing capabilities available on remote hosts. But how does it work? So let's start from the beginning. So when I do an SSH, I can just use my password. But if I put my public key to the authorized keys, then it's supposed to be working without any password, right? I think it's very well known. I can just use my private key and do the same. And if if it's a password protected private key, then I need to put the password. But this is not for the remote server. This is the password of my key. So how can I do it without typing the password? There is this SSH agent. So usually it's used like something like evil SSH agent, because when I start the SSH agent, it also prints out all the required environment variable. But because I'm using fish, unfortunately, I have to set the SSH agent manually. So let's set this one. Okay, fine. So I supposed to have the SSH agent SS out sock, so I can just check if any key is added to the agent. There is no identities, so I can add my identity. Obviously, I need to add my password, and now it's supposed to be added. This is the public key, so I can just do it again, and I'm logged in. But what's going on? What is in the background? So I created a small reverse proxy to check the details of the messages between the SSH client and the SSH agent. So let's start it. So first thing what we need is the proxy, which will create an additional socket, which is the agent sock. So I would like to use this sock as the SSH agent sock. What was it? Yes, outsock. So this is supposed to be changed. I would like to change it only for this shell, and now I can try with this one. So let's double check. Okay, so this is the new socket. This socket is created by this proxy, and it forwards all of the requests to the real SSH agent, which already configured. So let's check what's going on. Oh, requests and responses. So we need to understand these requests and responses. So the protocol is quite easy, and now we will ignore the first request. So let's start from here. It just so the protocol is very easy. There is 4 bytes message length at the beginning. So this is a 1 byte message. And after that, the message type, which is this request identities, which is 11 or 0b. And the response, again, it's very easy. It's just the length of the full message, the type, which is the answer, and the number of the keys. And we have a few keys, which is just some blob. It doesn't really matter. It depends on the format of the key, if it's RSA or ECDS or whatever. And this is the comment. So actually, this is just a string, so it's easy to understand. Well, and after that, it's time. So first, it was requested to list all of the available identities, and after that, it was requested to sign something. So this is where I prove that I have the private key, because I can sign the data itself. So this is the key, which is supposed to be the same key as here. So this is the chosen key, and this is some data which is supposed to be signed. These flags are not so very important. It's used mainly for the RSA, that you can set the required number of bits or so on. And this is the response. So again, length, type, and finally the payload, which is nothing more, just a signature. It's quite easy. So, but what is the first message? So we just ignored this very first ssh-agent C extension. But before check it, let's go back to here. So here I don't have any ssh sock, so I couldn't use it anymore. But I can forward it as we did it last time. So if I do the ssh minus big A, then it will be available here. This is the same socket, it's forwarded. Yes, this one. So this one magically forwarded to the original socket, so which is not very safe because this is just a socket file, right? So anybody on this machine with root permission actually can use this file. By default, I am the only one who has write access to it. But if there is any other root on this machine, on this remote machine, then the root can use this agent socket and just put some additional messages. This is how we sign the host keys, but it's any kind of signature. So the private key couldn't be exported because there is no such message. We can just put the private key. But we can use this capability to log in other machines. So to avoid this problem, there is this extension message, which was the very first message. We just ignored it first. So this is a custom message, and it can be any. So the ssh-agent should ignore if it's unknown. Where is the right? Oh, this. Let's check this one. So, and this one actually it's a very specific extension. So this is the extension. This is a request to the agent, and this is the type of the extension. If you would like to write your own extension, then you can use a different string. This is created by openssh itself. And here there is some information about the session itself. So there is this host key, there is this signature, which is created by the host private key, so it can prove that this host key is really true, and session ID, and some flags. So this actually helps to restrict the usage of SSH agents. So the problem was here that anybody can use with root access this socket, but the idea is that somehow we should restrict the usage of the socket, because not all of the signing capabilities are available from this host. This agent restriction is very well defined in this, I would call it design doc, which explains why it can be useful. But again, this is just an extension. The other interesting part is the protocol itself, which is somehow the short version of this design doc. It explains just the format, but without the motivation. And I would also recommend to read the specification itself. The agent protocol specification is a draft, but it can be checked. And for example, if we go to the end, we can see all the available message types. So these are just the responses, failures, and success. I think there should be another table with the values. Yes, so failure and success, extension, And the other part is mainly either just listing identities or signing a request or adding identities. So you couldn't uh, read the private key itself, as I mentioned. And the encoding is quite easy, but for string encoding or byte array encoding, it has a reference to the original SSH reference. But actually, this is just the length plus the UTF or string bytes. So it's not very hard to do it. So that's all for today. My main motivation was to understand if SSH agent can be extended to forward not only the signing capabilities, but for example, my password manager and using passwords on remote machine without copying there, which pretty well possible with this extension mechanism. It's not very easy, so probably it can be covered with uh, other videos sometimes, but it's definitely not for today. So see you next time.